Good morning. Today we're going to talk about key features of polynomial graphs. A lot of this is very similar to the key features that we talked about with quadratics, so we're going to seem like we're reviewing quite a bit here, but there are a few new things here at the bottom. First thing, real zeros. Real zeros are the same as your x-intercepts. So if I go ahead and find my x-intercepts on the graph there, those are my solutions. So my graph crosses the x-axis at -8, -3, and +1. Okay. Only difference between real zeros or solutions and x-intercepts is that intercepts should be written as ordered pairs. So I have -8, 0, -3, 0, and 1, 0. Okay. My y-intercept here on my y-axis is actually at a decimal, just approximated, so it's really close. So I am going to say that's at about -1.5. So I have the point 0, -1.5. Okay, so those three things are a lot of review from what we've done in the past. So zeros are your x-intercepts without the point. Your x-intercepts are the ordered pair, and then your y-intercept is where it crosses the y-axis. Okay, end behavior, if you remember, this first line tells us to look at the left side. So this is telling us to look at the left side because it's -infinity. And then we need to decide if this arrow is pointing up or down. It's kind of working in the downward direction, so to show that, I'm going to write -infinity there. Okay, the second line here is telling me to look at the right side. If I look at the right side, my arrow on this graph is actually pointing upward. So that's going to be a +infinity. This is a little different than what we did with quadratics because with quadratics, those were always the same. Okay, so now that we're doing polynomials, you'll have some that are the same and some that are different, and you need to be careful of those. Okay, domain is just asking how far to the left do we go and how far to the right. For our polynomials, we are going to go all the way across the graph, so from left to right, -infinity to +infinity. That should be the same for all of them, but my range will change, and keep that in mind, that kind of rhymes. Range will change. You need to ask yourself, how low does the graph go, and how high does the graph go? Okay, so if I look at this again, that arrow tells me that graph is going to keep going forever in the downward direction. So I have -infinity there. And if I look at the other side, I also have an arrow pointing up. Okay, so I'm going to ask myself, how high does the graph go? That shows me that it's going to keep going up in an upward direction forever. Okay, so domain and range happen to be the same in this problem, in this graph, but it will not always work out that way. Domain will always be the same, but range could change depending on the graph. Okay. Let's move on to increasing, decreasing, positive, negative. A lot of students struggled with this, but it should be getting easier now that you've seen it before. I'm actually going to try to highlight this. Okay, we started out by highlighting our graph when we were doing this before. Okay, so if I highlight the first part of my graph, going from left to right, it is increasing there. Okay, and then it happens to change direction at this top point, and now all of a sudden it is decreasing. Okay, so now it's going down. Arrow there. Okay, so we're decreasing here. Okay, and then at that bottom point, it actually changes direction again. So starting here now, my graph is increasing, and it's going to continue increasing forever. Okay, so this will help us out, especially since it's highlighted. Let me switch back to a pen. Okay, if I label my sides, I start with -infinity, and notice right here, this value is where my graph changed direction. So it went from increasing to decreasing. If I count, that's 1, 2, 3, 4, 5, 6. That is -6 on my x-axis. Okay, and then it decreases, but it changes direction again right here. And that is at -1. Okay, and then it goes on forever the rest of the way. So it's really easy to kind of show, if I look between these two numbers here, my arrow is pointing up. So I know that I am increasing from -infinity to -6. If I look between these two numbers here, my arrow is pointing down. So from -6 to -1, my graph is decreasing. And then after my -1, my arrow is pointing up again. So from -1 to infinity, my graph is also increasing. Remember, I put the U there to show that there are two intervals, or I should say two, more than one interval, where the graph is either increasing or decreasing. So you should include that U in there. Okay, so there's your increasing, decreasing. Do mark up your graph. It will make your life easier if you get in the habit of doing that. Lost my eraser there. Okay, so let's now talk about positive and negative. My positive and negative are always split up along my x-axis because positive is above the x-axis and negative is below. So the numbers I'm going to use for that are always going to be the same as my x-intercepts or my zeros. Okay, so I have -8, -3, 5, and then I just add my infinities on the side. So negative infinity, positive infinity. When you're looking at your graph, you just need to ask yourself, is this section over here above or below? Since it's below, we're going to mark it with a negative sign. Then this section here, between -8 and -3, is above, so that'll be positive. The next section is below, so that will be negative. And the last section is above, so that will be positive. We're going to list this out. Okay, so starting on the left side, between negative infinity and -8, we have a negative sign there. So negative infinity to -8 is negative. Then between -8 and -3, it is positive. It moves above the x-axis. Okay, and then -3 to 5, it is below the x-axis again. So -3 to 5 is negative. And then 5 to infinity is positive. Okay, so there's everything that we've done in the past. The rest of this is actually new. I'm going to ask you two things that seem kind of weird, but they're going to help you out when we go on to graphing. The first thing is leading coefficient. I just want to know if my leading coefficient is positive or if my leading coefficient is negative. And all we do is look at the right side of the graph. So the right side is going up if it's positive, and it is going down if it is negative. So if we look at this graph here, my right side is pointing up, so that means my leading coefficient is positive. We do not care what's going on the left side for this, for the leading coefficient, just what's going on the right side. Okay. The degree of the function is based on which direction, like if you compare the directions that they're going, so both sides, if they're going the same direction, that means the degree is even. And if they are going opposite directions, that means the degree is odd. So notice my right side is going up, but my left side is going down. So they're going opposite directions. That means my leading coefficient is odd. Okay, one other way you can look at that is if you were to trace your graph, the number of changes in direction actually tell you the degree, the actual number. So if I trace my graph, I'm going one direction there, and then change to another direction, so that's 2, and then change to another direction, so that's 3. So that means my degree here is actually 3. Okay, last thing. Okay, maxima and minima. Okay, we have relative and absolute. So let's talk about relative first. Okay, relative maxima are the tops of any hill. So if I look at my graph here, notice I have a hill here, and at the very top I have the point -6, 4. That is a relative maxima, -6, 4. Okay, minima comes from the bottoms or the valleys. So notice here I have a valley, goes down and then comes back up. So my ordered pair for that is -1, -2. That is a relative minima. Okay, it is possible that you can have multiple relative maximas and minimas in a graph. It just depends on what the degree is. Absolute max means it's the highest possible point on the graph. Okay, so if I look at this, is this the highest possible point on the graph? Well, I'm going to tell you no, because I have an arrow there that tells me my graph keeps going. So I will not have an absolute maximum there. Same thing with absolute minimum. I'm looking for the lowest point. Is this the lowest possible point on the graph? And again, I have an arrow there that is pointing down. So that means my graph is going to go forever, and I do not have an absolute minimum. Okay. What I want you to do now is I want you to hit pause, and then I want you to try the next graph, and when you are done, check your answers. I'm going to go ahead and put them up there for you. So hit pause now, try it, see how you do. Okay, so hopefully you did this. Go ahead and check your answers here. So the real zeros are x equals -5 and 3, or sorry, -3 and 5. X-intercepts are -3, 0, and 5, 0. y-intercept is 0, -5. End behavior, both are negative infinity. Domain is always negative infinity to infinity. Range, this time it goes on forever to the bottom, but at the top it stops at 0, so that's why that's a little different. Increasing, decreasing, and then I wrote negative on the wrong line, so make sure you pay attention to that. So this is negative here, and it is never positive. And then go ahead and check the bottom part as well. In this problem, we don't have an absolute maximum because both of those are at the same height, so that's why we didn't include that as absolute. Okay, so go ahead and hit pause, check all your answers. If you have any questions, let me know. Hopefully this helped you out a little bit. Have a good day.